Hello friends! I was excited to read about the recent discovery of large amounts of near-surface water on Mars in the Valles Marineris, the largest canyon in our solar system. This discovery was made using a Neutron telescope in orbit around Mars, and it's exciting because it's the first time that concentrations of water this high have been detected this near to the equator. We often measure water on Mars by mass percent. That's the mass of the water in a given area, divided by the total mass of everything, the water, the regolith, the rock. In the polar permafrost regions, near-surface water concentrations are estimated to be as high as 20 or 50% in some areas. But as you move closer to the equator, these values drop. Around 10% mass is more common at lower latitudes. Ice is less stable in these lower regions. Here, ice can sublimate, changing from solid to gas and escaping into the thin atmosphere. Now, how is the amount of near-surface water measured on Mars? Since 2001, high-energy neutron detector, FREND, onboard Mars Odyssey, has been measuring the amount of hydrogen in the top meter of the Martian surface. Hydrogen can occur in other compounds on Mars, but a vast majority is H2O, so measuring hydrogen can give us a very good idea of the distribution of water. FREND has a very wide field of view, so maps generated from its data have resolution in the hundreds of kilometers. It's hard to measure geological features with higher or lower levels of water. You just kind of get an average concentration of water in a large area. In 2016, the Trace Gas Orbiter was launched as part of the ExoMars program, with the fine resolution Epithermal Neutron Detector, or FREND, on board. This is another neutron telescope with a much higher resolution. So both FREND and FREND orbit about 400 kilometers above Mars and can map hydrogen concentrations down to about 1 meter below the surface. But FREND has a much narrower field of view and a resolution down to about 60 meters. So now we're starting to get a more detailed map of water on Mars. So how do these neutron telescopes measure water on the Martian surface? So both Earth and Mars are constantly bombarded with cosmic rays. These are basically high-energy subatomic particles that are flying around all over the universe. Our magnetosphere and atmosphere prevent most cosmic rays from reaching the surface of Earth. That's a good thing they do. Cosmic rays can cause damage and cause electronics to malfunction, but they also wreak havoc when they collide with strands of DNA, causing mutations and cancer. Mars has no magnetic field and a very thin atmosphere, so these rays collide with molecules on the surface, down to about 1 meter deep. When they hit the nucleus of atoms, they can knock a neutron off from the nucleus. So then you have these high-energy neutrons bouncing around and hitting the atoms around them. Different types of atomic nuclei absorb different amounts of energy when these interactions happen. Out of all the elements, though, bumping into a hydrogen nuclei makes these neutrons lose a lot of energy. Because of this, the areas of the Martian surface with high concentrations of hydrogen have fewer of these high-energy neutrons that actually make it out, that escape and go back out into space. Whereas areas with lower concentrations of hydrogen, more of these high-energy neutrons that are bouncing around manage to escape. So by counting the amount of neutrons released, both FREND and FREND use this technique to measure the concentration of hydrogen in an area and therefore the concentration of water. FREND has detected one of these areas of highly suppressed neutron emissions in the Candor Chaos, great name, which is an area of the Valles Marineris, and is relatively close to the Martian equator. The mass of water in the near surface could be as high as 40%. The researchers believe they've found water ice, but water on Mars can take a couple different forms. Water can be chemically bound in hydrated minerals, though usually these minerals contain about 10% water, but something like a highly hydrated magnesium sulfate can have up to 62% mass of H2O. However, it's hard to imagine this type of chemistry being the source of the amount of hydrogen measured in the Valles Marineris. The top meter of the surface would have to have ridiculously high levels of magnesium sulfates, or some sort of similar mineral, and it's very unlikely based on what we know of Martian geochemistry. Another less abundant form of water on Mars is adsorbed water. This is where thin layers of water molecules condense on individual grains of regolith. But by far the most abundant form of water is subsurface ice. This is where solid ice fills the spaces between grains of regolith and pores of rocks. Though neutron emission detectors like FREND can't tell the difference between these three forms of water, it's just highly unlikely that the amount of water being measured is either coming from hydrated minerals or adsorbed water. Though subsurface water is the most likely source of these measurements, this discovery leads to even more questions, like why hasn't this water sublimated into the atmosphere? There's obviously a lot more we have to discover about the Martian water cycle, but if this location is a source of easily accessible water in a very temperate region of Mars, we can definitely add Candor Chaos to the list of potential sites for future Mars exploration. Thank you for watching. This is my first space exploration video, so please like and comment and let me know if you have any questions.